Hey everyone, and welcome to Chapter 1 of Precalculus. All right, here's a list of the different topics that we will cover throughout Chapter 1. All right, beginning with Section 1.1 here, rectangular coordinates. Hopefully, a lot of this section is review for you, okay? And even throughout Chapter 1, we're going to cover a lot of different materials and expand on topics that you have covered in the past. So, we're going to move quickly, but feel free to stop and pause the video at any time. All right, so you guys are definitely familiar with the coordinate plane, right? The coordinate plane has two axes, the x-axis, which runs horizontally, and then we have our y-axis, which runs vertically. We have four different quadrants. Starting in the top right corner and moving counterclockwise, we have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Notice that in the first quadrant, both the x and y coordinates are going to be positive. As we move into the second quadrant, the x coordinates become negative, the y coordinates are positive. As we move into the third quadrant, both x and y are going to be negative, and in the fourth quadrant, x is going to be positive and y is going to be negative. All right, so let's get to a quick example here. Identify the coordinates of the following points. Give your answer as an ordered pair x comma y. Now, one important thing to make note of is that ordered pairs always have parentheses around them. Make sure if you are writing an ordered pair that it has parentheses. That signifies that it is indeed a particular point rather than just a list of numbers. So let's start with our red dot here. So it moves 4 units to the right and 2 units up from the origin. That leaves us with the ordered pair 4, 2. The green dot, notice we move 5 units to the left and 5 units up. This leaves us with the ordered pair -5, 5. The next one, we move 3 units to the left and 3 units down. Our ordered pair will be -3, -3. This purple one right here, 2 units to the right from the origin, 6 units down. The ordered pair is 2, -6. Right? And the gray one right in the middle, we've already referenced it. It's got a special name. That's 0, 0, and it is known as the origin. All right, the distance formula. The distance between any 2 points, x1, y1, and x2, y2 on the coordinate plane is given by the formula d is equal to the square root of x squared the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Let's do another example. Plot the points -3, 3, and 5, -1. Then find the distance between them. Well, to plot the points, we know the first one goes -3 units, so that's 3 units to the left and 3 units up. There we have our first point. Our next point is 5 units to the right and 1 unit down. That's 5, -1. So to find the distance between these 2 points, all right, we can label these ordered pairs. We'll call this first one x1, y1. This next ordered pair, 5, -1, we'll call that x2, y2. Now, it doesn't matter which ones you label as which, as long as you are consistent in using this formula. All right, so there's our line segment. Let's begin to find the distance. We have d is equal to the square root of x2. That's my second x coordinate, 5, minus x1, the first x coordinate, -3, quantity squared, plus y2, the second y coordinate, minus y1, the first y coordinate, quantity squared. We can do a little bit of algebraic simplification here. 5 minus a -3. Notice that when we subtract negatives, we are going to add. This gives us the square root of 8 squared. 8 squared is where we end up with 64, plus a -1 minus 3, that would be -4 squared, which gives us 16. Adding those together gives us the square root of 80. Now, are we done here? The answer is no, right? We want to make sure that we simplify any radicals. So what we need to determine, are there any factors of 80 that are perfect squares. And a perfect square is just something that you can easily take a square root of and get a whole number value, like 4 or 16. So, are there any factors of 80 that are perfect squares? Well, 80 is the same thing as 16 times 5. Using our properties of exponents, right, and properties of square roots, what we can do is we can take the square root of 16, which is 4. That becomes 4 times the square root of 5 for our final answer. The distance formula is derived from the Pythagorean theorem, in case you didn't know that. When finding the difference between two numbers, you are finding the distance between them. All right, keep that in mind for the rest of the year. The difference between two numbers is the distance between them. So when you're taking x2 minus x1, you're finding the horizontal distance between your x coordinates. When you're taking y2 minus y1, you're finding the vertical distance between your two different points here. So notice we have the Pythagorean theorem. C squared is equal to a squared plus b squared. All right, another example. Find the distance between the points 1, 3, and 3, comma, negative 2. Well, let's plot the points. 1 unit to the right and 3 units up. Next point is 3 units to the right and 2 units down. There we have the line segment that we are looking to find. To find the distance between them, let's use the distance formula. D is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. What's x2? Well, x2 is the second x-coordinate. That's going to be 3. x1 is the first x-coordinate. That's 1. y2 is the second y-coordinate. That's negative 2. y1 is the first y-coordinate. That's 3. So we're going to plug those in. We get 3 minus 1 quantity squared plus a negative 2 minus 3 quantity squared. 3 minus 1 is 2 squared will give us 4. Negative 2 minus 3 is a negative 5 squared is 25. So we have the square root of 4 plus 25, which gives us the square root of 29. Now this is a perfectly good final answer. Again, it is nice and exact, and there are no factors of 29 that are perfect squares. There is no way to reduce that radical. All right, the midpoint formula. The midpoint between any 2 points, x1, y1, and x2, y2 on the coordinate plane is given by x1 plus x2 over 2, y1 plus y2 over 2. Now notice this is called the midpoint because it is in fact a point. This is an ordered pair. This first grouping is the x-coordinate. The second grouping is the y-coordinate. Now, when you guys are finding the midpoint, one thing to keep in mind is that mid should remind you of the middle point. And another word for the middle of two numbers is also called the average. Notice here, you are taking the average of the x-coordinates and the average of the y-coordinates. That is how you're going to find the midpoint. So find the midpoint of the line segment joining negative 6, 1 and 7, 4. Again, not necessary, but always helpful to draw out a picture. We've got negative 6, 1 and 7, 4. We are trying to find the midpoint of this line segment. We take the average of our x-coordinates, that's negative 6 plus 7 over 2, and the average of our y-coordinates, 1 plus 4 divided by 2. Simplifying those leaves us with 1/2, 5 halves, right? 1/2, 5 halves. And again, these are great fractions. Get used to working with mixed numbers in this class, all right? Or sorry, improper fractions, not mixed numbers. Use improper fractions instead of mixed numbers, all right? It'll make your life much, much, much easier, especially once we begin to do more complicated calculations. Boom, there we have it. There is our midpoint. As we said earlier on, when you're using the midpoint formula, you are finding an ordered pair by taking the average of the x-coordinates and the average of the y-coordinates. All right, let's try another one here with fractions. All right, hopefully you guys all enjoy working with fractions. I know that I do. Again, we can start off by just plotting these 2 points and getting an idea of what we're trying to find. There we have negative 1/3, negative 1/3. Notice the scaling that I have here on our coordinate plane, and negative 1/6 comma negative 1/2. There is our line segment. To find the midpoint, we use our midpoint formula. Again, the average of the x-coordinates and the average of the y-coordinates. That gives us negative 1/3 plus negative 1/6 over 2, negative 1/3 plus negative 1/2 over 2. Now, when we are combining fractions, when we are adding fractions, we need to get a common denominator. Well, our least common denominator in this case is going to be 6. So that means I need to rewrite negative 1/3 with a denominator of 6. To do that, I can multiply this fraction by 2 over 2. Negative 1/3 is the exact same thing as negative 2/6. So that's negative 2/6 plus negative 1/6 would give me negative 3/6, which is the same thing as negative 1/2. Now, for the y's, we have negative 1/3 plus negative 1/2. Again, we're going to have to get a common denominator. Our least common denominator here, again, is going to be 6. So, how do I get a denominator of 6 for this first fraction? We multiply by 2 over 2. That gives me negative 2/6 plus, multiply the second fraction by 3 over 3, negative 3/6. Negative 2/6 minus 3/6 would be negative 5/6. All right, so we have negative 1/2 divided by 2, and we have negative 5/6 divided by 2. Doing even more algebra, remember that dividing by 2 is the same thing as multiplying by 1/2, right? If we're dealing with fractions, we can multiply by the reciprocal. That gives us negative 1/4, comma, negative 5 over 12, right? If I multiply each one of those fractions by half, the 2 ends up in the denominator of the top fraction. And there we have our midpoint, negative 1/4, negative 5/12. All right, there you have it. Important information from chapter 1.1. Next, we'll be moving into chapter 1.2.